Okay, so this is kind of take two that I completely confused everybody. But you get the idea for double displacement. It was pretty good, right? Yeah. So what I'm going to do is I'm going to make this video in a single displacement. I'll make a double displacement with the next class, and we'll push on from there. Clear? Yes? Okay, now. So single displacement is going to be, there are going to be four types. And I'm going to make this is actually going to be, this is equation writing video 2. Okay, I'll do one later, but this is 2, right? Single displacement. Clear? Okay? Now, so there are two basic formats for single displacement. Yes? And I'm going to list the four types. All right? Yes? This is actually very simple. I know, you've heard that before. Okay, so there are 3 forms like this and one like this. Okay? You ready? So, if I have a metal plus an acid, I form what? Anybody have any idea? I form a salt plus hydrogen. Now let me just say something about a rule. Okay? If I'm forming hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine, is that it? Where's the periodic table? Anybody give me one they can show me? Excuse me. Let's see, fluorine, chlorine, nitrogen, oxygen, yes. So those are written, if these are gaseous, if they're gaseous, and they're all going to be gaseous. The only one that would be in doubt would be bromine and iodine. Bromine could be a liquid. At room temperature, bromine is a liquid, and it exists as bromine, monoatomic bromine, Br. Iodine, at room temperature, is a solid, and it would be I, yes? But iodine can also sublime at room temperature into iodine gas, and bromine can go into a gas at very near room temperature. And if they're a gas, it's going to be H2, O2, N2, F2, Cl2, Br2, I2. Okay? They are called diatomic molecules. Yes? Do you understand that? Covalent bonding, nonpolar, the whole business, right? So you're going to get hydrogen, right? Yes? Now the next one, you have a metal. Now the key here is it's a very active metal. Okay? And plus water, you produce a base metal hydroxide, okay, plus hydrogen. Hydrogen.
Oh, it's kind of like when we put water on lithium. Right?
When you put what?
Water on lithium?
Yes, lithium and water, calcium and water, absolutely. Yes. Okay. And then the other one is a metal. A metal plus a salt yields a metal plus a salt. Easy? The other one is a halogen plus a salt of a halogen, okay? Halogen plus a salt of a halogen yields a halogen plus a salt of a halogen, and that's it. Okay? Those are the 4 types of single displacements.
You can also really just switch halogens.
Yeah, exactly. You Exactly. And we have to talk about activity tables, etc. But assume we're not going to do activity tables. I know. Don't worry, it doesn't matter. Assume all reactions go to completion when we're learning initial equation writing. Assume all reactions go. All reactions work, okay? So, now, this is what I want to do. I just want to do a quick example of each, and then we're done. Okay? Quick example of each. Yes? Okay. What was the first one? I have, what? I have magnesium. Okay? I'm not going to do the names and then the equation. I'm just going to do the stoichiometric equation, give it to you, all right? For instance, if I have magnesium, okay, plus an acid, hydrochloric acid, okay, yields, what's it gonna yield?
A salt which is magnesium chloride.
Magnesium chloride, very good.
Hydrogen.
Okay. You have to know the stoichiometry, yes, and how do you write hydrogen?
H2. So
H2.
to balance it out, you have to put 2 HCl.
Excellent. Have you done this before?
Yeah, grade 7.
Where? What school?
ASA, American International School.
Excellent. That was 4 years ago, though. That's no cheap trick. You know, doing it before and doing it 4 years ago is pretty good. All right, now, what was the next one?
Metal and water.
A metal, calcium is the fun one, plus water. When you do single displacement reactions, if you write water HOH, it's fine to do that. It's fine. If you ever write in this classroom water as HOH, I would say, not a problem. Okay? The formula for water can be written as H2O or HOH, either way. Okay? HOH is actually chemically more correct. Okay? Chemically more correct. Because water is generally a combination of not hydrogen and oxygen, but hydrogen and hydroxide. Okay? And that's going to equal what?
Calcium hydroxide, which is a base, plus hydrogen. That's H2.
2. Right? Yes? Right? See, that's easier to balance if you write it as HOH. Okay? So, easy? Right? What's the next one? Salts. We're actually going to do this lab. I think this is going to be the first lab we do once we get our room back.
Metal plus salt.
Yeah, we're going to go zinc plus copper to chloride. Zinc plus copper to chloride. I'll give you a hint. Zinc only has, even though it's a transition element, and we talked about transition elements using Roman numerals, etc. Zinc always has a charge of +2, unless it's really weird zinc. Okay? In your experience as young chemistry students, zinc is not going to have a charge other than +2. So what do you think the products are going to be? Yes?
Zinc chloride.
Zinc 2 chloride.
Yeah.
You still have to use the Roman numerals. Zinc 2 chloride
Plus copper.
plus copper. You have to balance it?
No.
Nope, balanced, right? Now, halogen would be the halogens in terms of activity, even though I'm not going to hold you responsible for this yet, but it's easy to tell you this. Fluorine is more reactive than chlorine, etc. So the reactivity it decreases top to bottom. So if I take something like fluorine and I add it to sodium chloride, I'm going to get, even though all these are going to work, the ones that actually do work are the ones where the more active one is a reactant, right? Yes? Okay, but this is gonna be what? Sodium
Fluoride. Plus
fluoride, good, excellent, plus
Chlorine gas.
chlorine gas.
So we
Exactly.
put a 2 by the NA2.
Correct. That's it. Okay? Yes? Now, what we'll do, the next class is we'll do either synthesis or decomposition depending upon what we decide to do. You know, one class will do synthesis, the other class does decomposition. And they're basically the reverse with some tweaking here and there. Okay? They're not, it's not hard. It's just a lot of information in one day at 10:50 in the morning. Okay, so don't be too hard on me, okay? It's all right. You guys are toast though, right? Yeah, you guys have had it. Yeah, I'm losing them. Okay? End of video. Okay.